is a table of force, mass, and acceleration. So there are three equations. Force equals mass times acceleration. Okay. And then if you solve this, for example, for mass is equal to force divided by acceleration. And then acceleration is force divided by mass. So there are three equations here. Hopefully you see that, are in agreement with that.
Yeah, I can see that.
Okay, so this table, in each one, they give you two of the three values. So not the best. So, all right, what you're going to do is tell me, let me put these in the chat. I'm gonna put these three equations in the chat. All right, and that way you can copy and paste them as you need to. So for
Okay.
example, for letter A, here's what I'm looking for from you from letter A. So I'll keep track of this, but I'm looking for the equation for acceleration. A equals F divided by M. Okay. And then the numbers without the units, the answer, and then the units. Something like that for A. Okay, so that's what I'm looking for from you. So for B, which of the three equations are you going to use?
We're gonna
Which one are we solving for here?
the M equals FA. Wait, we're looking at B, right?
Yeah.
Okay.
Uh, so are you solving for what is the middle column here?
Mass.
Mass. Okay. So mass, what's the equation? Which of the three equations is it for mass? Yeah, you just said it. It's F,
Mass time
F
there's
divided.
oh
Yeah, F
force
divided
divided
by.
by acceleration.
What is the force?
The force is 22,
Okay, and the acceleration.
5.5.
Okay, and then could you calculate that for us?
Yes. Let me just go to Desmos
Sure.
really quickly. The answer is 4.
All right, and then what are the units of mass?
4 kilograms.
Kilograms. Okay. So for C, here's what I'm looking for C. I want you to put into the chat the correct equation, the correct numbers, the correct answer, and the correct units.
Okay. I think I got this. Can look in the chat and see if I got it right.
What about the unit? What about the answer? And then what about the units?
Oh, I forgot that. Oops, hold on.
Yeah.
Hold on. If it's mass times acceleration, wouldn't I also have to multiply the 19 and the -2?
You have to decide which one they're asking for, which is force. And you're right, you have to multiply mass times acceleration. So you have to you're picking which equation to use based on what you're solving for.
Okay.
Is that okay?
Yeah. Let me just fix that then. Um, I can you check this out and tell me if it's right? Because I'm not sure if I did it right.
Okay, so the units are capital letter.
Oh, right. Oops.
That's it. But yeah, the rest of it looks great. Okay, so for D is a little bit weird. You're solving for mass. We know that mass is force divided by acceleration. But this time the force is in scientific units. No big deal there. When you're entering this into Desmos, which I will have you do, make sure that you put a fraction bar so that you have a top and a bottom. And if you've no idea what I'm talking about, let me know. But this is the formula here. I'd like you to at least calculate this one.
Okay.
Your answer will be in scientific notation, or should be.
Okay, I just typed the answer in the chat.
Okay, very good. That's reasonable. Um, okay, kilograms is the answer there. Very good. So for E, you kind of have a sense of how to do this here. Let me see. This table is pretty lengthy. Let me see if I can trim this. We don't need this anymore. Let me see if I can just crop it real quick. Yeah. Okay. It's up to E, right? Yeah. Okay. That'll make it easier for us. All right. So could you do the same thing here for E? Could you figure out the right formula, put the right numbers in the uh in the calculator and give me the final result, please.
Yeah.
And ooh, just maybe the order here is force, mass, and acceleration, in case that's unclear.
Okay, got it. Okay, here's what I typed in the chat.
We're good. Okay, so you're getting the handle of this, except we're not solving for mass in this problem. You're solving for acceleration. Um, acceleration is the last one,
Mm.
which is force divided by mass, which is what you have here, but it's -5. I don't know
Oh, I
if
didn't
you,
see a negative
yeah.
5.
Okay, so just maybe try that one more time. I just need the answer from you.
Okay, with -5, got it.
Yeah.
There we go. That's the right answer. All right, there we go. Just sent it in chat again.
2.5 times 10 to the -9. Yeah. Um, I'm not sure where they're going with this because it's just kind of a weird number. All right, so F, you're solving for mass. This time you are using that equation for mass. So make sure you use the second row here. Actually, I'm gonna start cropping out the ones we don't need. That'd be the best way to do it. All right. Okay. Hopefully you can see everything there. Go ahead and work that out for us, please.
Yeah, sure. So I typed this into Desmo Scientific, and here's what I got.
Yeah, but you're not giving me everything. You're giving me just the like I'm asking you to put every like tell me what to so I can copy and paste here for
Okay.
your work. It's all right. I'm messing this up here. This is F equals MA. That's one of the problems here. Okay. So that's why we're having trouble with this one. So yeah, you're gonna have to recalculate it. It's 2.8. All you have to do on your end is change the uh
Okay, got it. No wonder why the answer didn't look great in my opinion.
yeah, I would agree. It does.
All right, just send it to you in the chat.
So you got about 336 newtons. Is that right?
Yeah.
Okay. All right. So G, you're solving for force again. It's mass times acceleration. So go ahead and calculate that for us, please.
Oh,
Just give me
sure.
the answer. Just give me the answer this time.
Just the answer.
Just the answer with the right units, please.
Okay, I just typed it in the chat.
So there could be like significant figures. We'll worry about that later on. So H, you're solving for mass. Mass equals force divided by acceleration. The force is negative 150 newtons divided by minus 9.8. Could you calculate that for us, please?
Yeah, sure. Okay, here's what I wrote. Well, the answer, obviously.
All right, good job. All right, so I is solving for force. Force is equal to mass times acceleration, 128 times negative 9.8. You could calculate that for us, please, and give me the right units for force.
Yeah, sure. All right, I got the answer.
It feels like this is about five too many, but we are off just one. Mass is a force divided by acceleration, minus 225 divided by minus 9.8. So last one there. Calculate that for us, please, and we'll move on
All right.
to whatever else they're asking for. We'll go figure that out.
Here's Jay's answer. I think that's right. Yeah.
Okay, that looks reasonable. All right, any questions on that before we move on to question 8?
Nope, I'm good.
All right, so question 8 says, explain in your own words what action reaction pair is acting to help you walk. Describe the magnitudes and directions of these two forces. So you walk, I walk. What allows us to walk? I mean, what what propels you forward?
Um, uh, oh dang, I don't even know how to respond to that.
Okay. Well, how about you do this? How about you stand up if you can? I don't know if that's possible in this scenario, right? But can you
Uh,
stand up and not move anywhere? Just stay completely standing.
yeah, that can happen.
Okay. Now, now after you're standing, take a step in one direction. Doesn't matter which direction, just any direction, and try to focus on what you're actually doing to take that step.
Well, you're moving your legs. That's you're
That's
moving
right.
your
That's right.
yeah.
You're not moving your arms, you're not moving your, it's all in your legs. Okay. Now when you take a step, what do you do with your other leg that isn't moving?
You prepare for the next step.
Right. Do you push off the ground to some degree?
Yes.
Yes. Okay. So there you have it. So the action is that your leg provides a force forward or down. You can think of even as down. And the ground reaction, the ground pushes back with an equal and opposite force. So I'd like you to, in your own words, describe this as best you can. Basically, I'm giving you the cliff notes. Maybe you can describe like what you just felt when you stood up, took a step, and then took another step. Just write a sentence or two on that.
All right. Here's what I wrote.
All right, let me take a look here. All right, I like that. Okay, so now um, let's talk about the sketch here. Okay, so I'm going to hand draw a sketch. So there's the ground. There's you. Okay, and then your leg provides a force down, and then the ground provides a force back up.
Wow, it's a lovely drawing.
It's not my finest. Okay.
I like it.
Okay. You are welcome to make this better if you want, but I believe that is sufficient for what they want here.
Yeah.
Any questions on that before we move on?
No, I'm good.
Okay. Any more comments on my drawing?
No, that's all.
All right. All right. Explain the action reaction pair that is acting to allow the rolling motion of the tires of a car. So first question to you uh, hopefully this is obvious, is how many places does your car touch the ground?
Well, when we're driving, when it's being parked, uh, I don't know.
Okay. What does touch the ground on the car? Not everything touches the ground.
The
The
wheels.
wheels and how many, and actually, it's actually the tire. The wheel is inside the tire. How many tires do most cars have?
Cars have four tires.
Four tires. Okay. So you might mention that in your answer that there's four tires that touch the ground. So this time I will make a drawing, even though it doesn't ask for it. There is the ground. There is your tire. The car has a weight that pushes down, and the ground pushes back up. You can think of the ground pushing back up. That's called a normal force. Right. So the weight of the car is pushing down on the ground. The ground pushes back with a normal force. And just like the previous problem, it is equal and opposite. Yeah, I think this may be easier to see here. Guess not. All right, never mind. Okay. Um, so you want to put this into your own words. You can think of this is the action and this is the reaction.
All right.
You understand the scenario here?
Mhm.
Okay.
All right, here's what I wrote.
Take a look. Cars drives the ground. The action is the weight of the car looking down on the ground. The reaction is ground pushes back when force equal and opposite. Yeah, good. So even if you don't understand that, you definitely said that really well. Do you want to include the drawing?
Yeah, we can.
Okay. All right. Cars have four tires that touch the ground. The action is the weight of the car that is pushing down on the ground. And the reaction is the ground pushing back with a normal force which is equal and opposite to the weight. All right. Very good. Draw vectors on the object and figure to indicate the forces that are acting on them. Identify at least two action reaction pairs in the figure. Okay. So I will sort of highlight two places that I think are kind of where something is probably happening. One is right here. One is here, and another one is kind of here.
Oh wow.
Do you know about the show Mr. Ed with the horse, talking horse?
Not really. Not that it comes to
Okay.
mind.
It's a pretty old show. Your dad might know it. I only watched because it was late at night on Nickelodeon, Nick at Night. Um,
Oh,
but there was this talking horse, and the way they got him to talk is they put peanut butter in his mouth and his gums. Actually, that was the only way they get him to kind of move.
yeah. I think they did that with dogs as well when it comes to some of the.
Yes, yeah. Like horses don't normally look like this. This is very weird. Okay, so place number one is where the carriage attaches to the horse. Place number two is the carriage touching at the ground. Place number three is the hooves of the horse touching the ground. So you have to identify at least two action reaction pairs. I've identified three. I'm looking for a sentence or two that talks about, and we'll start with one, two, or three, whichever one you want here. Um, Give me
Let's
a
just do
sentence
one.
describing, okay. So that's the horse. The horse is sort of pulling, and the carriage, this collar saddle thing is kind of going the other direction, pulling back away from it, but he or she is pulling it forward.
Um, I think. Well, the horse is pulling it forward, obviously.
Right. So there's a force going, think of the force, there's a force going that way from the horse, and then there's a force going the other direction for the carriage. And they're equal and opposite. So give me a sentence or two that describes that, please.
Okay. So, like, should I start the sentence by saying there is a force that the horse is pulling the carriage forward
Yes.
and
Yes, exactly. Exactly.
All right, here's what I wrote.
Okay, let me take a look. We are close at time. Now, this is very important here is which is greater, F or C?
F.
That's right. So you want to say that the horse is pulling, that force is greater than the carriage pulling back because we would assume it's moving forward, like he's moving or she is moving forward. So can you give me one sentence here in the next 2 minutes that says that?
That
Well,
the what
the
I
force that the horse is pulling with is greater than the weight of the carriage.
okay.
That's what causes it to move forward.
Okay. There we go. Just typed.
Causing motion forward. Okay, very good. So tomorrow we can pick up here. These assignments are really long, but we could be able to finish this in our first hour tomorrow. We'll see. But all right, good job. That is it for us for today.